All right, now let me again recap that in quantitative research, okay, now what we are doing is quantitative research data analysis. Quantitative research. I've been telling you so many times there are three research approaches: quantitative, qualitative, and mixed method. So this SmartPLS is just a software. It is a statistical software. So it's not a data analysis. Okay, don't say it wrongly. So SmartPLS is a brand name of a statistical software, just like SPSS or EMOS or even Excel. So it is at par like Excel. It is just a statistical software. Okay. So this statistical software supports what we call um, structural equation modeling data analysis. Okay, it supports structural equation data analysis, structural equation modeling, or what we call SEM. Okay, SEM analysis. And let's go back to the basic of statistics. I've been telling this many times. Statistics can be generally divided into two. One is called descriptive statistics and inferential statistics. Okay, now inferential statistic can be branched out into two. One is called parametric, and the other one is non-parametric. So each parametric and also non-parametric again can be divided into two. One is on differences and the other one is on relationship. Differences and relationship. Okay, so when you do quantitative research approach, okay, it's about analyzing variables that look into either relationship or differences. It's either looking at relationship or differences. Okay, please remember this. Now, if you are doing survey research method, most of the time, I can say 90%, most of the time you are looking at relationship. You are looking at relationship. If you are doing experimental design, 90% of it, you will be looking at differences. Okay? So I hope you understand that. Huh? When you adopt survey research method, like most of you, I think majority of you will be adopting survey research method. In fact, all I suppose, survey research method, you will be looking into relationship. Okay, some of you ask me, am I going to look at differences or am I going to look at relationship? It's relationship. Okay, if you are doing experimental design, then you are looking at differences. Okay, I hope that explanation partly gives some insight to also Akmal Hafiz. I think I wanted to call you, but Akmal Faiz, I kept on forgetting that when you want to do experimental design, you are looking at differences. Okay, not suitable, even though it is appropriate, but what I can say is that it is not suitable to look into relationship. Okay, so relationship between variables. Basic will be one IV, one DV. That's the basic. So you are looking at relationship. Okay, when you use a V. All right. So when you look into relationship, okay, you have to know the statistical analysis that can be used. Statistical analysis that can be used. Okay. Now, before this, okay, most researchers, including myself, we use statistical software such as SPSS. Okay, SPSS. But using SPSS has its own limitation. Okay, one of the limitation of SPSS is that it cannot handle having more than 2 DV at a time, 2 dependent variable. So having 2 DV at a time, you cannot analyze concurrently or simultaneously. you have to analyze separately according to the number of DV. If your framework has got 2 DV, 2 dependent variable, so it has to be analyzed twice using using SPSS, and the statistical test that we use is called regression or multiple regression. Okay, so normally when you look at relationship, okay, we will be using regression. So this smart PLS, as I mentioned just now, it supports what we call structural equation modeling analysis. Structural equation modeling analysis, SEM. The short form is SEM, the acronym is SEM. So this SEM is actually an extended version of multiple regression. Extended version, advanced version of multiple regression. So when we talk about SEM, within SEM, you have got multiple regression, you have got path analysis, you have got variance analysis, so on and so forth. Many within many statistical tests is being embedded within structural equation modeling analysis. Okay, now I hope that gives you some insight, okay, why we use there are many other reasons, technical reason. I don't have the time to explain, and I don't think so you need that. If we are in a workshop session 2-day full time, maybe I can explain you on the detail. Okay, let's understand the terms used in SEM. Okay, now, by the way, talking about SEM, structural equation modeling, there are two types of SEM. Two types of SEM. Number one is called covariance-based SEM. Covariance-based SEM. Okay, so this covariance-based SEM is for parametric analysis. What do we mean parametric? Parametric normally meant for normally distributed data. Normally distributed data. That's the main reason. Second reason, it is being used for a framework which has a very strong theory. Framework where strong theory has been referred or used or adopted. So we use covariance-based SEM. So software that support covariance-based SEM is AMOS. Okay, AMOS is another software. Okay, whereas this one is called SmartPLS. SmartPLS supports another type of SEM. This SmartPLS supports another type of SEM, and the SEM that SmartPLS supports is called PLS SEM. Okay, PLS stands for partial least square SEM. So partial least square SEM is for non-parametric. So non-parametric means for data that is not normally distributed, or for a framework that is not based on a strong theory. Sometimes students ask me, okay, sir, my framework is being derived from a strong theory. Example, I have chosen this Maslow human needs theory. That is a very strong theory. Okay, but can I use SmartPLS? Well, the answer is yes, but you have to prove that the data is not normally distributed. Now, if your framework is being developed based on a strong theory, established theory, you just add 1-2 variables, but basically the remaining of the variables are taken from a very strong theory. And when you check on the data normality distribution, you found it to be normally distributed. If it is normally distributed and the framework is based on a strong theory, you cannot use SmartPLS. You cannot and you should not use SmartPLS. Okay, so you don't have any justification to support to use SmartPLS. You cannot use. Now, what if you have used it? Of course, you have used it, but it's actually inaccurate, not correct to use SmartPLS. Okay. If your framework is being developed based on a strong theory and your data is normal, then you should be using AMOS, software AMOS. Now, if your framework is based on a strong theory, popular theory, well-known theory, and then you still want to use SmartPLS, can or cannot? The answer is yes, yes. The answer is yes. But how do you justify? You can justify by showing that the data is not normally distributed. So there is a process, there is a step that you have to show. One is called univariate normality, and the other one is called multivariate normality. Okay, but I'm not going to show in this class because you all are doing, majority of you are doing research project. I think that is not very crucial to be included in the reporting. But those of you who are pursuing PhD, that one need to be reported and need to be shown in your report. Okay. All right, so let's talk about this term used in this SmartPLS. So we have got this term latent variables and observed variables. Okay, actually these variables you are familiar, but when it comes to this SmartPLS territory, they have been actually renamed. Okay, the variables you are quite familiar, but when it comes to the SmartPLS territory, the same variable have been re-tagged with a different name. Okay, let's go through this framework. Okay, this framework, perceived service quality, has got 5 dimensions: tangible, reliability, responsiveness, assurance, empathy. Okay, please take note. This one, perceived service quality. Can you all see my mouse pointer? Okay, circling the perceived service quality. Can you see that? Can somebody
Yes,
please? Okay, this is what we call concept. This is called concept, or we call it second order. In SmartPLS, we call it second order. Okay, second order. Concept with dimension. These are the dimension. Okay, tangible, reliability, responsiveness, assurance, empathy. You know, some of you made mistake, you know. You create a framework, you put the independent variable on the left side here, and then you put the concept as the DV. You put tangible, reliability, responsiveness, assurance, empathy, and then you take this perceived service quality as the DV. That is wrong. Okay. Some of you also did, you know, you put all several listed independent variables, and then you put the dimension, the DV here as digital citizenship. Whereas all the IVs are actually the dimension of digital citizenship. Okay, so that is wrong. So that digital citizenship must appear here, and then you have to search for another DV that is appropriate. Okay, so all of you understood this. This is called concept or second order. These are called the dimension. So from this diagram, you know perceived service quality is what? Is the independent variable. Customer satisfaction is the dependent variable. So remember, all variables need to be operationally defined. These are the definition. Okay, you have come across this slide before. This is just the repetition. Okay. Okay, now look at this diagram again. Now, tangibles, these are called dimension, but they are actually independent variables. So in SmartPLS, okay, or in SEM, it is called latent variables. So these are called latent variables. Latent variable, latent variable, latent variable, latent variable. Customer satisfaction is also called latent variable. Okay, latent variable. Okay, someone is joining. Okay, can you still see the PowerPoint slide? Because just now I just toggled to another window? Can you
Yes,
still?
bro.
Good.
Yes, bro.
Still. Okay. All right. So far we just learned one term, latent variable. Latent variable is actually the variable itself, latent variable. Okay, now these are the measurement. Remember, many times, some of you send your framework onto the WhatsApp group, and then you show me the framework, and then I said, it is okay, but be careful of your measurement. I ask questions, I pose questions to you, how are you going to measure? So this is what I meant by measurement. Measurement. Okay, measurement. Okay, some is easily measured, okay, because you have got the available instrument that you can refer. Okay, some variables do not have a readily available instrument, and you have to develop yourself. So try to avoid that situation. All right, just now we have learned what we call latent variable. Now we are going to understand what is meant by observed variable. Now look at this tangible dimension. Tangible dimension uses 4 items, okay, using the Likert scale type, okay. The library has modern looking equipment. So this is one item. These are called item. One item, two item, three item, four items. So these 4 items, they are called observed variable or manifest variable. Okay, observed variable. Okay, why do we say observe? Because the respondent observe the questions. They see the questions and then they fill up, okay, the answers. So that's why it is called observed variables. Okay, but in research method point of view, the normal term used is called item. Item, or sometimes they call it element. If you refer to Umar Sekaran, it is called element, or if you look at other books, it is called indicators. Somebody is turning on the microphone. Can you check who is turning? Oh, Rosiman.
Sorry, Prof.
Okay. No, no, no. Go down, go down, go and follow Mama. Take your meal first. Okay, can you still see my slide, everyone?
Yes.
Okay. All right. So let's look at this. Okay. So this is actually the representation that you're going to see in SmartPLS. So remember this one tangible just now, the variable, and then are using 4 items. Using 4 items. So these are called observed variables. This is called latent variable. So the latent variables is normally appearing in an oval or circle shape, whereas observed variables items appear in a rectangle shape. Okay. Now, another terms that you have to understand is called endogenous, exogenous. Now, endogenous is actually dependent variable. Remember D, endo. When you spell D, endo, in D, so it's equivalent to dependent variables. Okay. Exogenous, exit, going out, arrow going out, is actually independent variable. Okay, so in smart PLS or SEM analysis, they use different term. It's just like, you know, in KL we say makan, but when you go to Kelantan, you meet Akmal Faiz and then he will speak make. And then if you go to Indonesia, you follow me, then over there we will say mangan. Indonesia will say mangan. Okay, so it's different terms, but they are actually referring to the same thing. Okay, now look at this slide again. Okay, now this is the framework. On the top, you can see framework, customer satisfaction, customer loyalty. Very simple framework. Okay, 2 variables. Independent variables, customer satisfaction. Dependent variable, customer loyalty. Now, customer satisfaction using 4 items. Set 1, set 2, set 3, set 4. 4 items. These are called what? Observed variables. So this customer satisfaction is actually independent variable. So when it is independent, we call it exogenous. Customer loyalty is dependent variable. So dependent variable, we call it endogenous. Okay. So this is the actual representation in Smart PLS. The actual representation where all of you will be drawing it later. This is the actual representation in Smart PLS. So it is in the form of circle for the latent variables. okay, and then rectangle for the observed variables. Okay, another thing that you have to understand is what we call reflective formative. Okay, some of you, especially the PhD students like Ferdinand, asked me what is meant by reflective and formative. Okay, now this is the two terms that you have to understand, but for the sake of this class, I am going to focus on the reflective first. Okay, this is a very complicated concept that you have to understand, but for PhD students, you have got no choice. You have to really understand this, both reflective and formative. For master's students, both FLP and so full-time, you just have to focus on the reflective. Okay, now reflective is a situation where when you remove any item, the actual meaning, the actual operational definition will not change. Whereas formative is a situation where the removal of any item, the removal of any item will change the meaning of that particular variable or latent variable. Okay, so when any item is removed, the meaning will not change, then you use reflective. When any item is removed, the meaning is changed, then it's called formative. Okay, like uh, uh, in this semester, Aizat, how many subjects are you taking this semester, Aizat?
4.
4 subjects. Okay,
Yeah.
now in order to calculate your CGPA, all the 4 subjects, they need to have a score, right? You have
Yep,
to have
correct.
results for all the 4 subjects, then only you can calculate the GPA of this semester, correct or not?
Correct.
Now you cannot remove any of the subject. You have already registered for 4 subjects, so you need to have 4 results. Now let's say you fail in any of the subjects, still it has got a score, correct or not? That is 0 or probably
Yep.
F or probably E. You still have a score, correct?
Correct.
Okay, so when you cannot remove any of the item, so that is called formative. Just like the calculation of CGPA or GPA, you cannot remove any of the subjects. So the moment when you remove, the meaning will change. So that is called formative. Formative, the word form, formative. Now, example, let's say satisfaction. Okay, satisfaction is very huge concept. Okay, if you say satisfaction with the library, okay, satisfied with the employee, the staff, satisfied with the services, satisfied with the technology, satisfied with the furniture. Okay, then you take the score. Okay, satisfaction about the furniture, the people, the books, the collection, or the ambience. Okay, let's say 5 elements. Okay, 5 elements, 5 items about satisfaction in the library. Now, let's say a customer, a student, or a user of the library only not happy with the employee, one aspect only, but the rest he is happy. Okay, so we still take the majority. That means he is still happy with the furniture, he is still happy with the services, he is still happy with the collection, he is still happy with the ambience. Only he is not happy with the staff or the librarian. But 4 out of the 5 he is happy. So we still conclude that the respondent or the user is still happy, even though he is not happy only on one aspect, that is the librarian still happy. So this is the situation what we call reflective. Reflective means what? Even if you remove one item, even if he is not satisfied with one item, or that one item is dropped, you are left with 4, you still accept it to be as happy or satisfied. So that means that is what we call reflective. Okay, reflective. So that explanation about reflective and formative will require a very long lecture. I don't have the time to go into that, but for the master students, enough for you to focus on reflective. For the PhD student, master student, especially those under my supervision, you need to have a personal coaching, face-to-face explanation what is meant by reflective and formative. Okay. So in terms of this diagramming, for reflective, the arrow will be going out. Okay, this one, you can see tangible arrow going out. Whereas for a reflective, arrow coming in from the item, arrow coming in. So that is the difference between formative and reflective. Okay, so okay, this one, reflective versus formative. This is a concept. These are called dimension. This is the dependent variable or endogenous. These are called exogenous. Now, this concept, okay, concept in SmartPLS, it is called second order. Tangible, reliability, responsiveness, it is called first order. Customer satisfaction, atomic, okay, no dimension. It is atomic, singular. So it is called first order. Now, why perceived service quality is called second order? It is called second order because it has got dimension. Okay, it has got dimension, subset. Okay, so when you draw, okay, this one, you can see, so this is called reflective. Okay, you can see this one, perceived service quality, arrow going out. So this is reflective. And this one, tangible, reliability, all these are dimension of this service quality. So don't be wrong. This is not dependent variable. This is not dependent variable. Don't be confused. Don't say, hey, why in this diagram it's like this is dependent variable. No, this is not dependent variable. This is actually second order. This is actually concept of this. Okay. So this is called reflective. How do you know reflective? Because the arrow going out. This is going out. So this is reflective here. This is also reflective. Okay. Look at this one. This is reflective formative. This one arrow going out from the latent, and then from this latent, arrow coming into this latent. So this is formative. So remember I told you this is not dependent variable. This is second order. So this is formative. Okay. All right. So far, is everybody clear? We are just still discussing on the theory of this analysis. I hope you still following my lecture. Are you all following? Can you all understand? Anybody has problem?
Yes, Doctor. No problem.
Okay, no issue. Good. All right. So the process in analyzing structural equation modeling can be divided into two steps. The first one is called measurement model. The second one is structural model. Now, measurement model is also called confirmatory factor analysis, CFA, confirmatory factor analysis. So, in measurement model, you are going to look into convergent validity and discriminant validity. Okay. Now, the terminology, it's here given. The explanation of the terminology, go and search for yourself. There are so many information in the internet. I have got no time to go into the detail, but these are actually the steps that you have to follow through. Now, the measurement model is the prerequisite of structural model. Structural model is also called hypothesis testing. Hypothesis testing. Okay? Because measurement model is a prerequisite, you can never proceed to structural model until your measurement model is successfully developed. In other words, you fulfill all the benchmark requirements for the measurement model in terms of convergent validity and discriminant validity. It's just like you have to pass this research method, then only you can take research project that next semester. For MIM student, you have to pass research method, okay, MIM 790, then only you can take MIM 880. That is prerequisite. You cannot take project and then you take measurement model. Okay, that is absolutely not acceptable. In fact, it is absurd. Okay, so measurement model need to need to pass, then only you have to do, then only you can proceed to a structural model. Okay. I you know, I receive a lot of, you know, project, you know, by students and PhD students, you know, asking my help to analyze, you know, and then many a times, you know, the measurement model cannot pass, and then cannot proceed to structural model. So yeah, alhamdulillah, because of my what do you call, vast experience, I managed to look into the problems, and then I settle for their issue, then only they can proceed to structural model. Okay, so meaning to say, you can never test your hypothesis until your measurement model is completed, or is fulfilling all the requirements. So it's very important. Okay, so measurement model need to be completed, not merely saying completed in the sense that, okay, I've done. No, you have to fulfill all the requirements. What are the requirements? Convergent validity and discriminant validity. All right, now these are the steps involved. Okay, these are the requirements. Okay, I'm not going to go into the detail, because later on when we go through, you can understand. Okay, and then as I explain, you can always toggle and look into these slides again for reference. Okay, so when we explain the analysis later, you will go through all this terminology: composite reliability, or CR, okay, factor loading or indicator loading, and then the convergent validity in terms of AVE, variance extracted, and so on and so forth. Okay. Okay, now this mediation moderation, I'm going to skip right now. Okay. Okay, this is the web what do you call, to check on normality. Okay, univariate normality and what do you call, multivariate normality. Okay, now is everyone in front of the computer right now? And are you all ready? Have you downloaded all the files that I've shared yesterday? Hello?
Yes, Prof.
Yes, Prof.
Okay. So
Prof,
I'm going to
ready.
open sorry, it's a bit slow. I'm opening another window for the it's not working. Okay, can you see my window now? I'm opening Google. Can you all see Google? Can you use the interface? Everyone, can you please somebody respond? Can you
Yes,
see
Prof.
Google? Okay, can you type there web power? Web power. Web power. Can you type web power on your computer, everyone? Are you doing it? I need to hear voices. Please say something. Anybody?
Yes, yes.
Yes.
Okay, type web power. And then you can see web power. Sorry, web power. Statistical. Okay, this one, web power science.org. This one. Okay, can you get this interface? Web power, statistical power analysis online. Can you all get it?
Yes. Yes, Prof.
Okay. Fazli, are you with me?
Yes, Prof.
You can see that?
Yeah.
Okay. So you click on web power. Okay, search for, I think, where is this? Okay, slightly different than the previous one. With web power setting, normality test, normality test online. Okay, this one. Okay, can you see that? Univariate, multivariate, skewness, and kurtosis calculation. Ferdinand, can you see that? Can you get this website? All of you?
Yes, Prof.
You get this univariate, multivariate, skewness, everyone? Can or not?
Can.
Okay, now yesterday I've already shared the file, right? So you can, here you type of data, you click on CSV, CSV, comma, separated values and with data with variable names. Okay, data with variables names. Okay, done? Everyone done?
No, I'm having problem, dog.
What was the problem?
It brings me to the PDF format.
No. You have to, never mind. If you cannot follow, you just look at what I've shown here. It will not take you to the PDF format. Okay. Maybe you have typed wrongly the address. You go to Google and then you type univariate multivariate analysis. Okay. And then you browse and then you upload the file that I have shared with you yesterday. Okay, desktop. Okay, choose customer trust and satisfaction.csv. Customer trust and satisfaction.csv. And then click open. And then you just click calculate. All right, so you get the output. All right, now look at the last. Can you see the output? Can you see my output, everyone? Did you get the same output?
Yes, Prof.
Okay, now this value must be less than 0.05. The value must be less than 0.05. Like in my case, it is 0. It is 0. It is exactly 0. So that means it is exactly 0. That means it is less than 0.05, right? Correct or not, Fazli?
Yes, Prof.
So when it is less than 0.05, like in my case, it is 0, exactly 0. So meaning to say, this data is not normally distributed. It is not normal. It is skewed. Okay, probably negatively skewed or positively skewed. So it is not normal. So that justify that I can use SmartPLS because it is not normal. If it is normal, you cannot use SmartPLS. If it is normal, okay. Somebody sent to me, oh, my data is normal, I'm going to use SmartPLS. Okay, that is wrong. The data must not be normal. So you understand, all of you?
Yes, Prof.
Okay, done. So we are done on the first thing. That is the requirement for analyzing the using SmartPLS. So now you can open your SmartPLS that you have just installed. I'm going to close this window. Naim, are you still alive?
Yes, doctor. Yes.
Are you following?
Yes, I'm following.
Are you doing the same thing am I doing?
No, I'm. You are showing hands here.
What?
Yes, I'm trying.
Okay, good. Nining, are you following Nining? Nining Sudiar, tidak dengar ya? Rosiman, can you understand?
Yes, Prof.
Good.
Good.
All right. So now you can, all of you can please open your SmartPLS. I'm going to share my window now. Okay. Can you see my SmartPLS now, everyone?
Yes, Prof.
Yes, Prof.
Good. Can you all see?
Yes.
All right. All right. Yesterday I don't remember what file did I give to you? Remember what's the I gave you 3 files. Remember what are the file that I gave to you? Can
UM engagement, service quality, customer trust.
customer trust and satisfaction, and then digital library engagement,
Service quality and satisfaction.
Service quality
satisfaction.
and satisfaction.
Okay. All right. So we are going to use customer trust and satisfaction. Okay. So now, can you click file? Everyone click file. Create new project, and then you put there customer trust and satisfaction. Customer trust and satisfaction. Then you click OK. So you can see here appearing right on the left side of the window pane. Can you see? Customer trust and satisfaction, all of you?
Yes.
Yes, Prof.
Okay,
Yes, Prof.
now you can see double click to import data, right? Double click to import data. So click on that one, double click to import data, double click. So remember yesterday I already shared that file. So you pick that file. Huh? Now the file is in CSV format.
Prof, can you repeat again?
Repeat. Which one?
The content, how to import the content?
This one you already created and then double click to import data. Can you see? Have you created the project?
First project.
Yeah, customer trust and satisfaction, right? Isn't it? Okay, you double click and then you choose the file that already shared yesterday. Customer trust and satisfaction. Then you click open. Okay, and then you will see the file content will be appearing. Can you all see that? Can you all get that?
Yes, Prof.
Yes, Prof.
Okay, and then you can see if you enlarge this part, you can see the green color is actually the data file and it has got 365 records. That means 365 respondents. Now this data you can create using SPSS when you enter, but when you save it, make sure you save as CSV. Okay, or you can use Excel. No need to use SPSS also, no issue. You can still use Excel to enter the data. Okay, can you see that customer trust satisfaction appearing? 365 records, correct?
Mine.
Right.
All right. So now you click again on that blue and yellow color just above that data. Click again. Okay, so when you click, you will be presented with this blank space for you to create the diagram. Got it, everyone? Okay, so on top here, file, look at my screen, file, edit, view, themes, calculate, info, language. These are called the menu bar. Okay, and here you can see icons. These are called toolbar. Okay, this is the workspace, the blank one workspace. Now this is actually the cosmetic, the changing of the diagram that you draw on the workspace. Now you can just remove by clicking this, you know, small palette color on top of it. Click on that one, so that palette color will be removed. Okay, and then you can see indicators. Indicators are actually observed variables or items. You can scroll downward and you can see all the items are there. All right. Now, you can refer to the slides that I've given you, okay, yesterday. This is the framework, okay. I'm going to show this. Can you see the framework? Let me show you again. Sorry, in this mode, it's very difficult to conduct workshop. I hope you understand the limitation that we are experiencing. Okay, now can you see the framework? Everyone?
Yes, Prof.
Okay, how many variables are there? Saifur Rahman, how many variables are there? Saiful, are you with me? Or you are elsewhere? Saiful, are you following? Felicia, can you see my slide? Felicia Ajon.
Yes, Prof.
So how many variables are there?
Mm, 7.
Yeah, 7. Okay. Now, ease of use and customer satisfaction. Nadia, are you there, Nadia? Miss Nadia. Nadia, can you please answer my questions? Are you around? Oh, you. Razman, can you see my slide? Razman?
Yes.
Okay, this ease of use and customer satisfaction. What types of variables is this?
One.
I cannot hear you. Please say loudly. What types of variables are there?
Can you hear me now?
Okay, yeah. Yeah, what types of variables are there?
That one. Dependent variable.
Okay. Shahrul, Aimi, are you still alive?
Yeah.
Shahrul? What type of variables are there? Shahrul?
Yes, I am.
What types of variables are they? Ease of use and customer satisfaction. Moderating.
Hello.
Ah,
Can you hear me?
ya, apa dia Razman?
Something wrong with my. I think it's. I don't know lah. I don't. I'm trying. I think dependent variable.
Ayo, what happened to all of you lah? Sampai sekarang pun maksudnya all of you still do not understand, ah. That's why kadang-kadang belajar ni dia kena rotan tau. I remember when I was in standard 4, my teacher asked me what is the meaning, apakah perkataan seerti, what is the synonym of melainkan. Melainkan, So all of us were thinking, at that time standard 4, we didn't know, nobody could answer. And then he twisted, or she twisted our ear, my dear teacher at that time, Cikgu Ramla, twisted my ear, and all the classmates were twisted the ear. And then she said, perkataan seerti melainkan kecuali. Sampai sekarang, now I'm 50 years old, I can still remember kecuali. So when I say kecuali, it means melainkan. That's why next time I must twist your ear also. These are called what? Mediating variable. Astaghfirullahalazim. Where is my tasbih? Mediating. This is dependent variable. This is independent variable. Okay. Okay, I don't want to waste time. I know all of you are no time. All the time watching video, movie only. No time to watch this research methodology. Not interested at all. Never mind. Okay, now I'm going to toggle into my SmartPLS window for you to watch and see. Now, can you see? Everyone?
Yes, Prof.
Okay, I'm going to enlarge. Okay, remember just now from the framework, the most rightmost is trust. So you are going to take trust. Take trust. Now trust is actually TST1. So you click this one, highlighted TST1, and then use your index finger, press the shift button, and then you click TST4. So all the 4 will be highlighted. And then you press the mouse, As you are pressing, you drag, bring onto the workspace, and then release. Okay, can you please do that, everyone? Done, everyone? Dayang, can you do that? Have you done that?
Yes, Doc.
Okay. Now, make sure the color is red. The color red indicates problem. When it is turned blue, that means problem is solved. That means it's not problematic anymore. Now you can change the direction of the arrow, just the right mouse click, and then you can see here 4 options. If you choose this one, and then the boxes of the rectangle will be shifted onto the right. If you choose the one on the top, it will be placed on that position. If you choose this one, it will be placed on that position. So since it is the rightmost, so choose the one that is placed where the rectangle on the rightmost, like that. Okay, everyone? Is that okay, everyone?
Okay, okay.
Okay, good. Okay, now next one is ease of use and customer satisfaction. Ease of use and customer satisfaction. Okay. Customer satisfaction is CS1 until CS5. So highlight CS1, CS5, drag, bring it here. Done? Okay or not?
Okay, Prof.
Okay, now look here, bring your mouse cursor here, right mouse, click, and then rename. Rename, and then you put there trust. Click OK. This one you rename into satisfaction. Click OK. Okay, then we will continue with ease of use. Ease of use is PEU1, PEU5. Drag. Put here, rename, ease of use. Click OK. Okay, so the next one, you can refer to the slide now as you are doing information quality. Information quality is IQ1 until IQ10. Okay, IQ1 until IQ10. Now, this is a real data. This is one of my students that I supervise, so I use his data. So, but I already published this paper in a journal. Information quality. And next one is system quality, SQ1 until SQ8. Rename system quality. And then the last one is service quality. I think service quality what? Security, I think. Security, privacy. Now, okay, just leave it. Of course, at this stage, it's not so beautiful, never mind. So just put there, security. And then the last one, privacy. PRI, privacy. Okay, now everyone, are you all doing okay, everyone? Are you all still at the same pace with me?
Okay, Prof.
Yes, Doctor.
So have you all completed at this stage, like mine?
Yep.
Okay, good. So now you can see on the toolbar here, you can see latent variable, connect, quadratic effect, moderating effect. Okay, so you click on connect, and then you bring your mouse onto the center of the circle, click, and then you drag, okay? You connect, you click. Okay, now look at how the connection is done in my PowerPoint slide. Okay, that means each and every one, information quality, system quality, security, and privacy must be connected, okay, to ease of use and satisfaction. Okay, so finally you get all in blue color. The latent variable must be appearing in blue color. So when you have in blue color, meaning to say that the diagram is already correct. When it is still red, that means something is wrong somewhere. So you have to rectify that problem. Have you all reached this point, everyone? Can I hear voices, please, before I proceed further?
Yes, Prof.
Okay, all already in blue and yellow. Okay or not?
Prof, can you repeat how to drag?
What?
Can you repeat how to drag the arrow?
How to?
Drag the arrow.
Okay, you just click here. On the top, can you see connect? Connect, and then you click, and then you drag, and then you release. Click again. You click on the circle, drag, click on the circle that you want to connect to. Oh, what voice is that? So noisy. Fazira, your children are so many. How many children do you have? So noisy.
Doctor, I have some problem.
What problem?
I cannot install
What install?
this software.
Oh. We are already at the stage of drawing. Now you tell me you cannot install. Oh, mashallah, Naeem. Why you cannot install? What's the problem?
Yeah, here showing the a problem occurs.
What problem?
I'm showing. Doctor, I'm showing. You are seeing that?
No, I cannot see your screen.
Huh?
You present nothing. It's total darkness.
Darkness.
I cannot see anything. Never mind, Naeem. It's too late for you to tell me that it cannot be installed. We are already ahead. You just listen to what we are going to share, and then after this, you try by yourself. We cannot wait for you. Installation will take some time.
It's already installed, but processing. How am I processing? Is asking about key like that.
Yeah, I've already explained the problem just now. I said you have to install into the computer that has not been installed with that software before. You understand what I mean? Did you try a trial version?
No.
That one you have to figure out yourself. You're doing masters, so this installation is a job of Form 5 students, not a master students. Don't ask me about this thing. Okay. Are you guys still around?
Yes, Prof.
Yes, Prof.
Yeah.
Where is my... Okay, done, everyone? Fazli, are you also doing or you just listening?
Yes, I'm doing, Doctor.
Good. Okay, now can you see on the rightmost on the toolbar, can you see an icon called calculate? Can everyone see that? Hello?
Yes.
Okay,
Yes,
now
Prof.
you click calculate and then a drop down list will be appearing for you. Now you have to choose PLS algorithm. PLS algorithm. Click that one, PLS algorithm. All right. Now, maximum iteration. Just now remember, we have got 300 and how many data that we have just now? I think
365.
yeah, 365. So you click one, PLS algorithm, you change this one maximum iteration 365. 365. And then you click start. So it will calculate. Now, our framework is very straightforward, no issue. If your framework has got moderation, then there will be issue because you need to have a strong computer. All right, so can you see the output as mine? Did all of you get the output as mine?
Yes, doctor.
All right, so the first thing they have to do is that you have to look into this construct reliability and validity. This one, click on this one. All right. Now, whenever you see there isn't any red color, that means everything is okay. If there is no red color, that means it is okay. All right. All right. Now, the Chromebook alpha here, this one must above 0.7. Just now in my slide, I showed to you some tables. So in the tables, actually, I've given you the benchmark values that the score should achieve. So for Chromebook alpha, the value should be at least 0.7. Rho, the value should be at least 0.7. Composite reliability, the value should be above 0.7. Average variant extracted or AVE, the value should be above 0.5. Okay, now, but we cannot be so complacent. We cannot be satisfied at this point. You have to go to what we call outer loadings. Look at outer loadings. All right. So in the outer loading, it will show you the what we call loading for each observed variable. Loading for each observed variable. Now, the ideal, the best value should be more than 0.7. But sometimes, under certain circumstances, we can still accept 0.45 or 0.5 or 0.6. We still can accept. But the best is always 0.7 and above. Okay, now if you look at this, you scroll downward, you can see some of the items are red color. So suggesting that the score is less than 0.7. So like this one, IQ1, IQ10, IQ2. So all these value less than 0.7. You scroll downward, then you can see SQ1, SQ2 also less than 0.7. Okay. Okay, now, for this class, let's say we are going to take 0.7. But that 0.7 is not absolute. Okay, sometimes we can use even 0.4, 0.5. Okay, so let's say we're going to take the ideal value 0.7, meaning to say we have to delete all the red color. Okay, all the red color we have to delete. So let's start with information quality, IQ1, IQ10, IQ2. So you click on this diagram again. So you can click select, you can drag, you can just space out so that you can see clearer. So IQ1, IQ2, IQ10 has got low value. So you can see it has been, IQ1, IQ10, IQ2, low scoring. So what you need to do, you have to delete. So you just click select, click this one, press delete, press delete, press delete. And then you can rearrange. Okay, 3 items have been deleted. Okay, and then you can run again. Click, run. Just now we have deleted information quality, not yet system quality. You run again, you start, calculate, and then you can go to outer loading. You can see, is there any more reds? Of course there are. That is SQ1, SQ2. So you go back and you delete SQ1, click this one, SQ1, SQ2. And then you can rearrange, okay, so that it looks nice. Now you can even hide the rectangle. The rectangle can be hide. You click and then you put there hide indicators. Hide indicators. Okay, so here you don't see any indicators. You don't see any observed variable. put the ease of use in between, in the middle, and trust at the end, like this. So just now, let me again stress that we have already deleted 3 items from information quality and 2 items from system quality. Okay, and then you can run again. Okay, and then you go to construct reliability, validity. You can see all green, no issue. If it is red, that means there is an issue. And then you go to outer loading, then you can see all are in green, that means no issue. So have you all got what I have accomplished, what I have obtained? Have you all got, everyone? Am I still connected with you? I don't listen to any voices.
Yes, doctor.
Okay. Dayang, are you still at the same page with me?
Not yet. I'm stuck at the deleting Q10, Q1, Q2.
Okay, I will wait for the rest also. I give some time. The rest, if you need for me to wait, I'll do that. Okay, in the meantime, you can take like 5 minutes, 10 minutes break. The rest can continue. But anybody who has got anything that you want to ask, you can ask now. Ferdinand, are you all following?
Yes, Prof.
Any issue so far?
No,
Clear?
but I'm clear. I reduced the data to 99 because I'm using students.
Come again?
I reduced the data to 99 just now because I'm using student license. I already
Okay.
installed.
Okay, understood.
Prof, doctor, I'm stuck. What shall I do after I delete?
Yeah, you can run again. Run again. Click calculate. Have you deleted 2 items from system quality?
Not yet.
Go and do that. Remember the 2 items that you have to delete just now? 2 items from system quality.
Is it SQ1, SQ2?
I don't remember. Which one did I delete just now? Show indicators. SQ1, SQ2. Yes, Q1 to Q2. Sharul, are you okay? Sharul?
Yeah, Prof.
Okay. Aizat, are you okay? Aizat, are you okay or not? Saiful, are you following? Are you doing the same thing? Am I doing?
Yes, doktor. Dapat. Alhamdulillah.
Good. Nining, can you follow Nining? Nining.
Yes, Prof.
Boleh ikut. Are you following? Have you installed the software?
I have installed the software, but I cannot to follow you. Always lost you many times.
Okay. Never mind. Later on when you come back, I will again meet you, then we can have a personal coaching.
Thank you very much, Prof.
Okay. Nining, can you please mute your microphone?
Okay, Prof.
Good. Okay, are you all ready for the next step, everyone?
Yes, bro.
So have you got
Yes,
the
yes,
results like mine, every one of you?
Yes, Professor.
All right, now, are you seeing my same SPLS, Smart PLS output, all of you? Can you see my screen, Smart PLS?
Yes, Prof.
Yes,
Yes,
Prof.
Prof.
Okay, now you can see this system quality, these are called factor loadings, factor loadings. Now, as I said, the ideal value should be above 0.7, but under certain circumstances, okay, 0.45, 0.6 can be accepted, but the ideal one must be 0.7. Okay, so these are called factor loadings, factor loadings. Factor loading. So these are called the latent. The blue color are called latents. The yellow color are called the observed variables or indicators. Indicators. So now we are going to do the reporting. How are we going to report? Okay, so this is the measurement model. What we are now doing is called measurement model. So you go back to your output. You go back to your output. All right. So you click on outer loading. Click on outer loading. Click on outer loading. All right. And then you click on Excel format. Click Excel format. Click Excel format. Now you open your Excel.
Is it export to Excel?
Yeah, Excel format. Excel format. Excel format. Not export to Excel. Excel format. You click outer loading. Click Excel format. Correct? Then you open your Excel. Okay, can you see my Excel now, everyone?
Yes, Prof.
Then you paste, click paste.
yes.
Okay, then you can see there. All right. So now you bring all the values here, you copy, Control C, bring it here. Bring, then you delete. Bring this, Control C, bring it here. Delete this one. Copy this one, Control C, bring it here. Delete here. Take this one, Control C, bring it here. This one delete. Bring it here. And copy this one, Control C, bring it here. All right. Okay, then is it okay, everyone?
Yes, Prof.
Okay, then you put a table like this. You need like this column, this column, this column, and then another 4 column. So bring down here. You put a box. So you delete this one. Try to space out so that you can see. So CS until CS5, these are customer satisfaction. Customer satisfaction. Okay. And then IQ 3 until IQ 9 is information quality. Information quality. PEU, perceived ease of use. PRI, privacy. SEC, security. SQ, systems quality. PS, trust. Okay, done. Okay, this one you can label this one. This one we can put the variable. This one item. You put the item. Then item loading. Item loading. Then you put the Chromebook alpha. Chromebook alpha. And then this one row. Composite reliability. Average. Variance. Extracted. It is how you do your reporting. This is called measurement model. Measurement model. Now, Chromebook alpha and row is not very crucial. Normally, the crucial one is composite reliability and average variance extracted. But if you are doing PhD, you have to report all the 4. Okay, never mind. You just take the minimum first. Delete. Take this one, composite reliability, average variance extracted. So where are you going to get this value? You're going to get the value from SmartPLS. It's there. Okay, it's there. So how do you know? You go back to your SmartPLS. Okay, everyone, can you see that construct reliability and validity? You click that one. This is where, okay, number 1 here, ease of use. You can take, you copy Excel format, and bring to your, here, copy, paste. Okay. Okay, just now ease of use. You just take these 2 value. Okay, composite reliability, average variance extracted. They take these 2 value, Control C. And then ease of use is this one. Then you copy, Control B. And then information quality, Control C. Oh, sorry. I didn't show the. Can you see now my Excel, everyone? Nampak tak?
Yes, Prof.
Okay, you copy,
Yes.
You just take 2. Okay, this one, ease of use, Control C. You bring it here, perceive of ease of use. And then information quality, you copy, Control C. Information quality, this one, put it here. And then privacy copy, Control C, where's privacy, put it here. And then satisfaction, put here satisfaction. Security, system quality, and then trust. Okay, so this table you must report. Remember this one, composite reliability must be above 0.7. Average variant extracted must be above 0.5. As you can see, all the score surpass the required value, so no issue. Factor loading, item loading must be above 0.7. So we are done with measurement model. Now, what if your composite reliability not meeting the requirement? In other words, the score is 0.3 or 0.2. So if it is 0.3 or 0.2, that means it is very low. You have to start deleting one item, start from the lowest item. So you delete one item and then you run and then see. If after deleting items and then you are remain with 2 items only, the highest 2 items, still you cannot get 0.7. So what you need to do, you have to drop the whole variable. You have to delete the whole variable. That means information quality, the whole construct, the whole latent variable need to be dropped from the framework if it cannot surpass 0.7 or at least 0.7. Okay. Example, let's say privacy here for item. Let's say here is 0.2. So 0.2 is very low. So you have to go back and start deleting from the smallest value on the item loading. So you delete one and then you run. You delete one, you run. If you have deleted 2 and the minimum, remember, must be 2. Until you are left with 2, still the value cannot get 0.7. So you have got no choice. You have to drop the privacy variable in your framework. Okay. Now, what if all the items, what if all the variables, katakanlah semua variables, all the variables, you cannot meet 0.7 and 0.5 respectively. For average variant extracted AVE, it has to be 0.5. Now, let's say you cannot achieve 0.7 for composite reliability and you cannot achieve 0.5 for as average variant extracted, even after you have deleted many items and you are left with 2 items only for each variable, and you cannot meet that score 0.7 and 0.5 respectively. So meaning to say you cannot fulfill the requirement of the more measurement model. So when you cannot fulfill the measurement model, you cannot proceed to hypothesis testing, that is structural model. So when you cannot proceed to hypothesis testing, that means your framework is useless. Your finding is invalid. That means it can be just thrown away. Okay, that means your study is useless, cannot be used at all. Are you all following, everybody?
Yes, Professor.
Yes, Prof.
Understand or not? Rosiman, you faham tak?
Doctor,
Yeah.
what happened if that, what should we do if that happened?
What should we do? You cannot do anything. You have to drop.
And find do another framework?
Not do another framework. That means the framework is not problem. The instrument is problem. The items. That's why you have to do pre-test correctly. You have to do pre-test, pilot test. That's why for all of you master student by research project, master students, I advise you not to create your own instrument. Reuse what other researcher had done. That's why every time when you propose framework, I ask you, how are you going to measure? My point is that, did you really get questionnaire that you can actually adopt? Okay, don't develop your own. If you develop your own, you will face the problem that I have just explained just now. Normally, if you have done pre-test, the person involved in the pre-test is genuine in giving the responses and you have done thoroughly, you will not have that problem. normally. But if you have done your print test not comprehensively, that means you randomly pick anybody on the road and ask to do the pre-test, then you can expect to experience the problem that I have just mentioned. Are you all following? Faham tak Syarul? Syarul di tengah makan dodol ke?
Ya.
Faham tak?
Faham.
Bagus. Supian Supahan, awak faham tak Supian?
Faham Prof.
Bagus. Where is Naim? Naim gone already. Now, some of you are having problem with the software. You should not leave the meeting. You just listen. Just listen slowly. Later on, you can do it by yourself. We cannot wait for you to install the software. It's not possible. Betul tak Fazli?
Betul, Prof.
Takkan kita nak tunggu dia install? Saya dah bagi instruction semalam untuk install. Kenapa tak install?
Doktor, boleh tanya soalan?
Yes.
How about discriminant validity, Doktor?
Ya, kita belum habis.
Oh, belum, Doktor. Okay, baik. Thank you.
Alright, okay, now. Now, please remember, just now when I said in my slide, measurement model ada dua. Satu kita panggil convergent validity, satu lagi discriminant validity. Okay, what do we mean by convergent validity? Okay, I'm going to show you again. Stop presenting. Okay, can you see my SmartPLS output, everyone? Hello, can you see my SmartPLS?
Ya.
Okay, now measurement model atau dipanggil confirmatory factor analysis, dia measure two things. What is called convergent validity. Apa maksud converge? Converge maksudnya how good. Look at my mouse pointer here. Convergent maksudnya how good this item SQ3 sampai SQ8, how good it measures system quality. That is called convergent validity. Okay, how good this IQ3 until IQ9 measure information quality. Okay, that is convergent validity. So how do we measure? Kita measure gunakan CR, composite reliability, and AVE, average variant extracted. AVE must be above 0.5, CR must be above 0.7. Okay, so that is called convergent validity. Now, satu lagi is what we call discriminant validity. What do we mean by discriminant validity? Discriminant comes from the word discriminate. Discriminate means difference, differentiate, differentiate. So that means satu lagi is discriminant validity. Just now convergent validity, now discriminant validity. Discriminant validity means what? How different is system quality and information quality. How differ information quality and security? How differ security and privacy? How differ privacy and satisfaction? How differ satisfaction and use? How different use and trust? Okay, in other words, how differ is one variable, one latent against other variable. So that is called discriminant validity. So now discriminant validity, dia ada dua criteria. The traditional one is called funnel and lacquer. Funnel and lacquer. Okay, you go to your output PLS algorithm. Underneath you can see discriminant validity. Discriminant validity, you click this one. Okay, now can you see this, everyone? Discriminant validity, funnel and lacquer. Funnel lacquer criterion. Can or not? Hello?
Yes, Prof.
Can, Prof.
Okay, now you click Excel format. Click Excel format. Okay, tak payahlah. Sama juga, you click and then paste. Okay, I just explain here. Tak ada masa. Now, you look at the topmost, yang ini. Yang ini dipanggil yang the topmost for every column. This column, this column, this column, this column, this column, this column, this column. You look at the topmost value. The topmost value. Now, the topmost values must be highest compared to the bottom and also left to the left. Contohnya kat sini 812. It has to be bigger than the bawah ni and the left. Ni 0.1812. Lebih besar daripada ini, lebih besar daripada ini, lebih besar daripada ini. Okay, correct. Yang ini lebih besar daripada ini, lebih besar daripada ini, lebih besar daripada ini. Okay, everybody understand Malay, right? I think no foreigners here. I speak Malay. I think no issue. Okay, now this value is of use is the square root of AVE. Okay, just now you go here, is of use, this one is of use ni AVE 077. Okay, you go back here, this one is of use, the square root ni dapat 0.811. Now yang the rest bawah tu itu semua adalah correlation. Kalau you understand correlation, Pearson correlation, that is R value, Pearson correlation. So if you don't understand all these statistics, never mind, you just remember this. The value above this one mesti lebih besar daripada yang ke bawah dan yang ke kiri. Kalau you lepas yang itu, that means you have fulfilled discriminant validity. Okay? Like in this case, no issue. Semua lepas. Semua lepas. Ini 844 lebih besar daripada bawah, ini lebih besar daripada kiri. Ini lebih besar daripada bawah, lebih besar daripada kiri. Okay? Now, tapi kalau you buat PhD, ini tak cukup, you kena pergi kepada heterotrait, monotrait. Tapi saya tak nak explain. Yang ini untuk kelas PhD yang lain lah. Sebab tak ada masa. Masa pun dah nak 2 jam.